Hi, I'm Rebecca Weaver. We're going to be looking at Chapter 4 today, the exponential and natural logarithmic functions. So first up is Section 4.1. This is an algebra section, not necessarily too much calculus in this section. So if you're having trouble, that's where you want to look, is back to your college algebra book. So first up for our definition of an exponential function, it is a function whose exponent is the independent variable. That just means the x is in the exponent, and we have some sort of base that that x is on. Here's a review of our properties of exponential functions. If you'll remember, for the product rule, and this is all algebra-based, if we're multiplying two numbers and they have the same base, we add their exponents. If we have a base, he is to a negative exponent, that just means that's 1 over that quantity. If I divide with exponents, you would just subtract your exponents. If you have a power raised to a power, so it's some base raised to the y, and you raise all of that to the x, you multiply exponents. That would be the base to the x times y power. If I have two different bases, a to the x times b to the x, I could rewrite that as a times b all to the x power. That's called the power of a product rule. If I have a to the x over b to the x, I could write all of that as a over b all raised to the x power. That's called power of a quotient rule. So if we're gonna need those when we're doing some simplifying and when we're doing our calculus. So we just need a little bit of review here. So we're going to be simplifying some exponential expressions first. So for this first example, we're going to write these two different functions either as 2 to the kx or 3 to the kx for a suitable constant k. Notice that 1 over 81, that's some power of 3. So it's 1 over 81 all raised to the x over 2. For the b part, we're going to be doing 2 raised to the 5x plus 1 all over 2 times 2 raised to the negative x. So let's do the solution for the a part. We notice that 81 is divisible by 3, some power of 3. So after a thorough investigation, we realize that that is 3 to the 4th. So we're just going to rewrite that 81 is 3 to the 4th. Then we can rewrite that 1 over 3 to the 4th as 3 to the negative 4, all raised to the x over 2. Then we're going to use our power rule where I have a number that's raised to a power all raised to another power. We're just going to multiply those two, so it's going to be negative 4 times x over 2. Simplifying that, we'll get that as 3 raised to the negative 2x. That's a little easier on the eyes. Might be a little easier to take the derivative of too. For the b part, we need to simplify that denominator first, and then we're going to combine the numerator via the base of the exponents, 2. Therefore, we're going to get 2 raised to the 5x plus 1 all over 2 to the 1 minus x, because that 2 standing alone is the same as 2 to the first. All of this then can be simplified. I'm just going to get 5x plus 1 minus the quantity 1 minus x. Doing that simplification, I'll get 2 raised to the 6x power. If you go to graph any of these exponential functions, you'll see that they all go through the point 0, 1, because any of these spaces raised to the 0 power is 1. And they all have a very similar look. The positive bases that are greater than 1 are all increasing in value, and then those functions where our base is in between 0 and 1, those are going to be decreasing functions. So next we need to solve the following equation for x. This is just using algebra here. I've got 2 minus 3x times 5 raised to the x plus 4 times 5 to the x, all equals 0. First step, I see that both of those two terms have a 5 raised to the x in them. So after writing down my given equation, I'll factor out that 5 to the x. Then what I'm going to do is simplify that's inside, and I'll get 5 to the x times the quantity 6 minus 3x. This is in terms of factors, so I can just set each factor to 0 and simplify. Now 5 raised to the x, I can't take 5, raise them to some power and get 0, so that's not going to work. But I can simplify 6 minus 3x and say that x is 2. Okay, so that is it for this first section. You'll be doing a few algebra problems all related to those exponentials. If you have any questions, be sure and send me an email. Have a wonderful day.